So welcome back. It's good to be with you again. My name's Keith Penn. This is Module 2 of the Getting Ready to Teach International GCSE Physics. In Module 1 yesterday, we looked at the outline of the presentation of the specification and the content. Today, we're going to look at assessment, really, understanding the assessment objectives for the qualification, understanding the question types and mark schemes for the qualification, have a little chance to practice using the mark scheme, using some exemplar student work, to look at the way in which practical skills are assessed, to consider exam technique and time management in an exam, and to learn a little about the support provided by Pearson around assessment and exemplars. My name's Keith Penn, and I've been a teacher of physics over 33 years in 8 different state schools, comprehensive schools, mainly around London and East Anglia. And I'm joining you today from just outside Cambridge in the UK, where it's a little bit milder than yesterday, but still very much looking like rain. I hope you're having better weather than we are at the moment. Let's start on today's session. Brief recap of how I introduced yesterday's session. Pearson Edexcel is the world's leading learning company and as the UK's largest awarding organisation, best placed to provide qualifications aligned to the British educational system. Our international heritage stretches back over 150 years, and today we partner with schools, universities and employers worldwide, offering world-class, globally recognised qualifications to over 3.5 million students every year. We're a trusted and recognised qualifications partner to 6,500 schools, colleges and employers globally. We mark over 10 million exam scripts on behalf of the UK Department for Education each year, and we operate in 70 countries worldwide. We'll start with an assessment overview. As mentioned yesterday, there are 2 different routes of assessment. Linear route, which has been going for several years, first launched in 2018 on this particular specification, and a modular route, which is just being developed and first teaching from this September, with first exam from next summer, May, June 2025. If you're happy with the linear approach, there's absolutely no pressure to move to the modular route. Both options are going to continue to be offered, so our linear international GCSEs will continue to be offered and taken widely by students around the world. In the modular route, unit assessments can be taken over multiple exam series. Grades are calculated on raw marks, which are then converted to a uniform mark scale, and students can resit individual units in any exam series. So very similar pattern to modular courses that used to be in existence and exist in other subjects too. Once a student has all their unit results, they can cash in these results for their grade. The linear route, assessment for all units are taken together in one exam series, so a single, well rather 2, but 2 exams at the end of the course. Grades are calculated on raw marks only, and students can resit assessments for all units together in one exam series. So you can resit the exam, you can't resit individual parts. The grade that students receive are calculated at the end of the exam series in which they set their assessments. At the moment, we're the only exam board to offer the choice of modular or linear routes for students taking international GCSE qualifications. If you believe the modular route will be a benefit to your existing students and could perhaps help you attract more prospective families to your school, Pearson can support you in moving to this route for your selection of subjects. It doesn't have to be all or nothing. You can offer modular in some subjects and linear in other subjects. Craig's saying not available in the UK. It's that mixed pattern. It's available in independent schools, in other words, fee-paying schools in the UK, and some of those are fee-paying international schools. It's not available in state schools, state-maintained schools in the UK. Assessment objectives. First of all, what are the assessment objectives? There are 3. The AO stands for assessment objectives, so there's AO1, AO2 and AO3. AO1 is knowledge and understanding of physics. AO2 is the application of that knowledge and understanding, analysis and evaluation of physics, and both of those assessment objectives are responsible, account for about 40% of the marks. You can see on the right-hand side in the GCSE. So between 38 and 42%, fairly tight percentage that the people setting the exams have to work within. So AO1 questions will account for about 40%, application questions from another 40%, and the remaining 20% comes from experimental skills, analysis, and evaluation of data and methods in physics. So primarily asking questions based on the practical elements and experimental and investigative elements of physics, AO3. If we break this down into the units, you'll see that the weightings are slightly different in paper 1 and paper 2. Okay, so you can see there's a slightly higher weighting, and it reflects the fact that paper 2 includes assessment of all content, that which is for students doing the physics part of a combined science course, whereas physics paper 2 includes the assessment of all the content, the content common to both separate physics and the physics element of double award science. And so that's reflected in the weighting there. You can see that there's a slightly higher weighting in paper 1 than in paper 2 on AO1 and AO2. Okay. Okay. What types of question are asked? We just listed these yesterday, and I said we'll be looking at some examples of each of these and talking a little bit about how to help students prepare for them. Both papers include a mixture of different question styles, including multiple choice questions, short answer questions, calculations, and extended open response questions. And that's true for modular as well as for linear options. Okay, this is an example from a paper 1 of a multiple choice question. Fairly standard multiple choice question. This question's about waves. Which of these waves is longitudinal? And students have to choose one of the options, A, B, C, or D, infrared, radio, sound, or ultraviolet. It's worth us being aware as teachers, but it's even more worth making sure that students are aware that there's no penalty for a wrong answer. Students sometimes think they kind of start with a pile of marks, and if they get a wrong answer, a mark is knocked off there. That's not the way it works. They're not penalised for wrong answer. Obviously, they don't get a mark, but they don't lose anything from what they've already got. So there's no advantage whatsoever in leaving the answer blank. You're supposed to put a cross. So I don't know if you can see on your screen, there's a very vague greyed square with a sort of white cross in the middle of it, and students fill in that cross with a pencil or a black pen. So yes, you're supposed to cross against the correct answer. And students can improve their odds, of course, even if they don't know the actual answer. They might think, oh, I think it's one of these two. They can improve their odds of getting the right answer by eliminating those that they know it can't be. And then, you know, if they're only down to 2, then they got a 50% chance of getting it right. Even if they have no idea of the answer, you got a 25% chance of getting it right. So please encourage students not to leave these blank. It can be done with a pencil on the multiple choice questions, yes, as long as it's clear. Because if you remember when I said yesterday, the papers are scanned and then sent digitally. So as long as it's visible on the scanner, it will go through to the marker. Here's an example of a short answer question, again from a paper 1. Question is about food preservation. Shows how gamma radiation, so the diagram shows how gamma radiation is used to irradiate fruit stored in a wooden box. The radiation kills bacteria on the fruit. You can see the diagram shows the gamma source and wooden box containing fruit. The question is, explain why gamma radiation is used instead of alpha radiation to kill bacteria. Worth emphasizing, it's an explain question. Okay, the command word in this question is explain. And you can see in the fainter print to the right hand side that there's a number 2 in brackets, and that means that there are 2 marks available for this answer. And it means that students won't get away with a single word answer. It's an explanation question, which means that their answer has to have the word because or something that means because in their answer. This is what happens because and an explanation. So it's an explanation question. Here's a calculation question. So this part two. Part one is a straightforward content AOI question, state the unit for current. AO1 rather, but part two here is an example of a calculation part question. The full question has several parts, but the second part that's shown on screen here is a calculation question. You can see the table of results, and there's a blank in the middle of the column for energy in joules. It says calculate the missing value of energy for the voltage of 4 volts. Give your answer to two significant figures. At GCSE level and international GCSE level, if the question specifies significant figures or asks for the answer to be given to a number of significant figures, then that is a marking point. One of the two marks available for that part of the question will be for stating the answer to two significant figures. 2 points here really. Students sometimes mistake significant figures for number of digits after the decimal point, and they're not the same thing, of course. You know, two significant figures might be 2.1 or 0.21, so two significant figures. So it's important that students know that. It's also worth saying that if students show a reasonably sensible calculation but make a mistake in it, even if they've stated the wrong answer to two significant figures, they can still get that second marking point. They can't just write any old number to two significant figures, but if they've made a fair stab at the calculation, so showed they're working, but made a mistake in that, they can still get the second mark for being able to give an incorrect answer to two significant figures. Okay? If the question has not asked for significant figures, then that means it's not a marking point. You'll remember that when I showed the weighting for each of the assessment objectives, there are 40% for AO1 and 40% for AO2 and so on. There's a limit to how many marks can be given for any one thing. So it's not a marking point in every single question. So as a physicist, I would say what should be done is they should state their answer to the same number of significant figures as the least precise value that goes into the calculation. But it's true to say they will not be penalised if they write it to a different number of significant figures. It's only when the question specifically says about a number of significant figures that will be a marking point for that question. But of course, it's good practice for students getting to the hang of writing it to the same number of significant figures as the data that's going into the question. That's different when you get to advanced level, of course. Students will be expected at A level, if they're doing A level physics, to do that in every answer, but at GCSE, it's only if the question specifically mentions a number of significant figures that it will be marked, that will be a marking point. Extended open response questions. Here's an example of an extended open response part of a question, again from a paper one. The full question has several parts, but only one EOR section. I've shown you 3 dotted lines here, but the actual question in the paper are quite a lot more lines provided. The whole of the rest of the page is filled with dotted lines. I just expanded the top part so you could see the question clearly. So there's quite a lot of space for the student's response in the question paper. The extended open response questions tend to come towards the end of the paper, but it doesn't mean they're the hardest question on the paper. They might be the hardest to mark because the marking is quite complicated, but they're not the hardest necessarily to answer. Please encourage students to attempt them, even if they're not confident of getting full marks. It's actually not very common for students who attempt the answer to achieve 0 marks. There's a sort of grading within the question. So it's, you know, and like in this example where there are 4 marks available, it's relatively straightforward to get the first 1 or 2 marks and a little bit more difficult to get marks 3 and 4. So do encourage students to try them. Sometimes students look at questions like this and think, whoa, that's way out of my league, and just move on, don't tackle it at all. Please encourage them to have a go, because it's actually relatively straightforward to pick up some marks in such a question. Can the student exceed the given lines? There's a rider on that, really. Bear in mind what I said about how the papers are marked. When I was talking to you about how Results Plus works, that the papers are scanned and the questions are sent off digitally. The whole paper is actually sent to the marker, but they're focused on that particular question. So if the page that the question on will go to the marker, but if they go on to another page or on the back of the page or onto an extra piece of paper, the marker won't automatically see that. So if they're going to expand their answer so it goes onto a spare piece of paper and even an extra sheet of paper, they need to indicate that on the page itself, see attached sheet, and then the marker will go looking for it. They won't automatically look through the whole of the rest of the paper just in case a bit of the question has been written somewhere else. So the question is, stick within the lines that are given. There's usually more space than they actually need. They don't have to fill the lines, but if they do have to extend it, or if they've made a mess of it and crossed it out and want to go on elsewhere, make a note within the question space to see extra lines on such and such a page or on the added page, so they'll go looking for it. Okay, certainly recommended to stay within the lines, as you say. What are mark schemes? Okay, sounds obvious. Obviously, they're the answers to the questions. Sorry, I missed a page. Did you see that page? No, there we go. Sorry. What are mark schemes and examiner reports? That's what we're looking at. So here's just the front pages of them. So the mark schemes include the answers to the questions, but they often give a number of alternative answers that students might also give and give an indication about whether marks can be awarded for those alternative answers. And they may also advise the marker of common errors, what to reward and what not to reward. Examiners are encouraged to use the mark scheme positively and to look to reward marks for what is there rather than penalise students for what isn't. I'm sure we'll come back to this, but it's a common issue when teachers who aren't themselves exam markers mark questions coming from an exam. We tend to sometimes be a bit more harsh than the exam markers are themselves, because we'll see a mistake in a question and automatically think we've got to knock a mark off for that. That's not how examiners are encouraged to mark. They're encouraged to mark positively, and if an answer fully meets the criteria for full marks for that question, then full marks is what it gets. Even if there are mistakes within it, if it meets the criteria, then it gets the full marks. Okay, so when we'll come on later to looking at marking exemplar questions, we'll sometimes find when teachers or groups of teachers get together and blind mark questions and then compare their mark with that the examiner gave, we often find that teachers are harsher markers than examiners are. And that's because of this issue about using the mark scheme positively and not just knocking off marks when there's an error in there. What's in the mark schemes? Okay, this is an example, a screenshot from a section of a mark scheme to paper one. Not really to read in great detail, it's to illustrate the type of information that's contained within the mark scheme. Obviously, the left-hand column, question number, is just the number of the question that it refers to. The widest column, the answer column, there's the type of answer required for marking point 1, that's what MP1 stands for, marking point 2 and marking point 3 and so on. While in the notes column, the third column, acceptable alternatives are shown and further clarification where needed. So you can see in this case, for example, marking point 2 says use of the plotting compass to show direction, could gain that mark. But also you can allow if compass is seen in the diagram pointing in a suitable direction. Okay, so alternative possibilities. You can see for marking point 3, there's a further method detail can gain a mark, but it does allow equivalent materials to cards. So it could say paper or plastic or whatever. Okay, so it gives you some possible alternatives that can be given. All marks may be given from the diagram, so a suitable diagram can attract all three of the marks. The right-hand column shows you the maximum number of marks available. So even if a brilliant student has managed to put 4 good points in there, they can't get more than 3 marks for this question. That's the maximum. If a student answers a question that is relevant, but that particular part of the answer is not in the marking scheme, what is the rule on this? Good question. Basically, if it's another way of stating the same answer, or if it's an acceptable, accurate, correct answer, then the rule is that markers are allowed to give it. So often it will say all words to that effect or something like that within the mark scheme. So they can word it in different ways. They don't have to necessarily use the exact words that are in the mark scheme to get the marks, as long as it means the same. And obviously, the more complex the question, the more opportunities there are for students to do that, to word a correct answer, but in a different way. What they won't get marks for is if they've said something which is correct physics but doesn't answer the question which has been asked. And that is a common error. Students will sometimes look at a question and think, okay, what's this question about? I will write what I know about that topic. And then they will write something which is perfectly correct physics but doesn't answer the question that was asked. The key to that really is the command word. What is the question asking me to answer? And what I always say to my own students is glance back at the question. When you've written your answer, glance back again at the question and think, have I answered the question that was asked? Because it can be heartbreaking when you're marking a student's attempts at an exam to think, here's a student that knew the physics, but they can't get the marks because they haven't answered the question that was asked. So the general rule is fairly liberal. If he answers the question using different words or different explanations, but which are perfectly valid, they will get the marks for it. But if they've written something which is correct physics but doesn't answer the question, no marks. This is the second part of the mark scheme for the same question. To illustrate that diagrams are included where they might help the marker. Very often, a good answer in a physics question will at least include and sometimes be entirely a well-labelled diagram. And so often diagrams appear in the mark schemes as well. So here it is within the mark scheme specifically, and it has explanatory notes in column 3. So you can see the field diagram shown for two repelling magnets, or magnets with the repelling poles close to each other. But you can see the additional notes that should show no lines linking the south poles. Not every line needs to have an arrow. Reject mark if the directions contradict. So if you've got some arrows going one way and some the other, then you don't get that particular mark. 2 marks maximum if any of the lines overlap. In other words, if they cross over, the lines must be separate from each other, but you can allow lines to be touching. So quite a bit of detail about what can and what can't get those 3 marks within the scheme. It's worth spending just a little time looking at the general marking guidance. This is what comes at the start of the mark scheme, and a bit like when students get into the exam, on the front page or just inside the front page is what we call the rubric, all the information about the exam, which is important about what sort of pen they should use and how many marks are available and all this sort of thing. And students in their excitement or nervousness will often skip over that and move straight onto the questions within the paper. And often they miss important information, so it might be worth highlighting that with them before they go into an exam. In the same way, when teachers are using mark schemes, they often skip over the general marking guidance and get straight into the questions. And there's some important information in here. So it's just worth us spending a moment or two looking at it, because it addresses some common misconceptions which can arise when teachers have not themselves been exam markers. You might want to think of some of the phrases which emphasize wherever possible, the aim is to credit good work rather than to punish errors. So it says all candidates must receive the same treatment. Examiners must mark the first candidate in exactly the same way as they mark the last. Particularly this comes into if you're using past papers or questions from past papers to make mock papers or tests or even end of topic tests or even homeworks for your own students. It's really easy if you know which student has done the questions, whose work you're marking basically, to be liberal on, oh, here's a student, I know that student really understands this. So you tend to give them the benefit of the doubt if they've been a bit ambiguous in their answer. Whereas another student with exactly the same answer, you might think, I know this student is a bit weak. I know they don't really know what they're talking about. So I wouldn't give them the benefit of the doubt. And in that way, we can subconsciously be prejudiced in favour of the student we know. I strongly recommend when you're marking your own students' work that you mark it blind. You don't look at who the student is until you've marked the question, because in that way you're giving it, all candidates must receive the same treatment. Obviously, exam markers don't know the students at all, but it's giving that point. Examiners must mark the first candidate in exactly the same way as they mark the last. The mark scheme should be applied positively. Candidates must be rewarded for what they've shown they can do rather than penalised for omissions. And I said a little bit about that a moment ago. Examiners should mark according to the mark scheme, not according to their perception of where the grade boundaries may lie. So they have to refer to the mark scheme and give marks according to what that says the marks are for. There's no ceiling on achievement. All marks on the mark schemes should be used appropriately. So as I said earlier, even if they've made a mistake in there, they can get the full marks. All the marks on the mark scheme are designed to be awarded. Examiners should always award full marks if deserved. In other words, if the answer matches the mark scheme, even if there are errors in there, it gets the marks. Where some judgment is required, mark schemes will provide the principles by which marks will be awarded. And this kind of answers the question that was put by Hassan a short while ago. It gives you principles. You can mark answers which generally mean this, so they can say this or something that means the same. The last part I think is important, and is important for students to know. Crossed out work should be marked unless the candidate has replaced it with an alternative response. Sometimes students, and this is particularly conscientious students, will get to the end of, say, a calculation and think, oh, I've made a complete pig's ear of that, I've got that wrong, and will scribble it out. Encourage them not to scribble it out. If they want to cross out work and say, this is not my submission, they just put a single line through it, because if, as often happens, student has crossed out a piece of work which is correct, it will still be marked and they'll still get the marks for it, even if it's been crossed out, as long as the marker can see it. If there's an obvious alternative, if their answer was yes and they've crossed it out and then put no, obviously they can't be awarded marks because they've hedged their bets, they've covered all the bases, as it were. But if it's not contradicted by a subsequent answer, they can still get the marks for correct working and so on that's being crossed out. So as I say, encourage students to put a single line through it, not to scribble it out with thick black pen so it can't be read. Okay. Yesterday, when we were just introducing the content, we looked at this example of a question. And the question I put to you then is which specification points are being looked at. And if you remember, it's a bit of a trick question because there were two parts of the specification where it could be questioning. The bit where it was looking at waves and sound waves in module 3, but it also was relevant when the same idea comes up in Doppler effect in astrophysics topic 8. This time, I'm asking you not about which content is being tested, but which assessment objectives do you think are being assessed in this part of an exam question? So do you think this is assessment objective 1 or 2 or 3? You don't have to put your answer into the chat group. I'm just giving you a moment or two to think about that. So the assessment objectives are being reproduced there down in the bottom left-hand corner of the screen. Which assessment objective or objectives are being tested in this question? Questions only ever test one or two assessment objectives. You never get a question which will test all three assessment objectives. So your answer might only be one assessment objective or 1 and 2. And the answer is assessment objective 2. Thank you to those who put in those suggestions. It's assessment objective 2, application of knowledge and understanding, analysis and evaluation of physics. Students tend to struggle, according to the examiner reports which come out after every set of exams, students do tend to struggle with questions such as this, which test knowledge and understanding in a different context from that in which they probably learned it. Students who've been taught the course will know something about the Doppler effect. They'll know about moving sound sources and how it affects what they hear, the pitch, the frequency of the sound, whether the moving sound source is moving towards them or moving away from them. And you might well have given them examples such as things which make noise, ambulances, emergency vehicles, racing cars, ice cream vans, anything making a loud noise as it drives past them, how the pitch changes depending on whether it's coming towards them or moving away. But it's unlikely, I think, very lucky if you have, but unlikely that you'll have used this specific example, swinging a buzzer around you on a string. And so the context is different. Students are being asked about physics they've been taught, but which is being set in a context that they haven't been taught. And students find this really difficult. They really struggle and often will instantly put their hands up in the air and say, I haven't been taught this, rather than thinking or having the confidence to say, I've learned the physics, I'll have learned it in a different context. Which physics do I apply to this situation? And it is a matter of confidence rather than learning often. And as I say, that's an area that students tend to struggle with. They tend to struggle with knowledge and understanding that's in a different context from that in which they probably learned it. If I can just digress for a moment, I do training in other sciences, and a couple of years ago there was a well-publicised example in the UK exams where in a biology section students have been learning about osmosis or being tested on osmosis, and the example they'd probably done, every school had done example where they cut potato into chip-shaped strips and then measured the strips, put them in salty water or sugary water of different concentrations, and the chips would expand or shrink depending, so discussing osmosis, investigating osmosis. The whole country would have done that with potato chips. An exam question asked exactly the same question, but said there were strips of carrot. And the number of students who, metaphorically or otherwise, threw their hands up in the air and said, I haven't been taught anything about carrots, and simply didn't realise that the information, there's science that they learned about osmosis was relevant to all root vegetables. They didn't have to go through every single example of a root vegetable. It threw lots and lots of students because the question set asked about carrots rather than potatoes. So it's really important that we try to give students the confidence that when they've learned something in physics or any of the sciences, that it can be applied to other areas. That's why scientific learning is so powerful. When you've learned a general rule, you can apply it in lots of different circumstances. And that's an area which students really show that they struggle with in exam after exam. I would say that, as I say, I do prepare training on feedback from examiner reports, and it comes up every single year. Examiners will say that students struggle with these sorts of questions, and it's not just an accident that they're going to appear. The people setting the exam, the setters, are required to put in questions which ask questions set in a different context from how it was probably taught. So these sorts of questions are going to come up. It's down to us to build confidence in students by giving them examples, and perhaps even after an experiment saying, we've just learned about this, what other context might this apply in, so that students know they might be asked to think outside the box. How can I apply this general rule to a different situation which I haven't met before? So, sort of answering the question before we get to the slide, how can we encourage students to develop confidence in tackling questions where the context is different from that in which the concept was initially learned? Okay, I've answered my own question there, really, just to emphasize. We really need to give students opportunities to consider this, so that each time we've taught a piece of physics or looked at an experiment and seen what is the general rule that comes from this experimental investigation, think with students, what other context could this be applied in? It would be impossible to second guess and teach in advance every possible different context which examiners might come up with. The key is in developing confidence, as it says in the question on the screen, developing confidence in students that they've learned the scientific knowledge and understanding and have the ability to apply it to understanding other similar situations where the same scientific ideas and principles apply. Question's a good example that's embedded in the specification because, as we mentioned before, the same concept comes up in topic 3, waves, and in topic 8, astrophysics, in very different contexts. One is talking about the Doppler effect in sound waves. One is talking about the Doppler effect in light waves, so moving at many, many times faster, but the same principle, the Doppler effect. So we develop that confidence by regularly asking and discussing such other context questions, giving students past paper questions and other questions which test the knowledge they've just learned in a different context. And also perhaps by encouraging students and doing it with them, reading and discussing science-related items from the news and other sources where we can apply our scientific understanding to real-world situations. Anything that gets students to think that physics isn't just what they've seen in the physics lab, it can be applied to the whole world. You know, if they read a report on something about the International Space Station or about climate change, anything that has a relevance to physics, that they can use the physics they've learned in the classroom context to apply to a wider world. That's the power of it. So exactly what Farouk has said, giving them everyday examples that are relevant to the topic and giving them past paper practice, more exam practice. I mean, obviously from the exam board side, I would obviously want to wait on that, but I can't overemphasize the importance of giving students lots of opportunity to see what questions have been asked in previous years, to see how many different contexts might be applied to the same bit of physics. That's where Exam Wizard can be really powerful, I think, because if you've just taught an area of physics, you can select out past paper questions that specifically look at that area of physics, and it will give you examples where the same physics is questioned in different contexts, so students can see how the same physics might be questioned in many, many different ways. Okay. A really useful resource for teachers and departments and for use with students themselves are what we call the exemplars. This slide shows the cover of one such. It's downloadable in PDF format from the same website that I was showing you the homepage of yesterday. It's in Teaching and Learning Materials. So this is the cover of a set of exemplars. And this example is not really for detailed discussion of the content. That comes in a moment, just to illustrate the type of information that's included. Not only are these exemplars collated together in booklets like the one I've shown you on screen, but they're also produced in the examiner reports after each live exam series. So when you go through examiner reports, they contain many exemplars like these. And as you can see from this snapshot on the right, the exemplars include one or more examples of students' attempts at a question. So it will show a question from the paper that's just been sat, and will give 2 or 3 students' attempts at that same question. With commentary, it gives you the examiner's mark that was awarded and some commentary on why that mark was awarded, why that mark was justified. They're really, really good for getting inside the mind of examiners, for distinguishing the features which make a good answer, and for learning how to interpret the mark schemes. So let's have a go ourselves. Here's an extract from one of the exemplar activities. I want you to look at the part question that's shown on the right-hand side, and the answer, the mark scheme, that's shown at the foot of the slide. And on the next slide, in a minute or two, I'm going to ask you to award marks for 2 examples of real students' attempts at this question. So, first of all, the question says, students' results are given in the table, and you can see the table of results there. Number of metal discs, minimum current. You don't need really the detail of the experiment itself, but you can see the table of results. And the question says, on the grid, you've only seen the top part of the grid here, but on the real paper, there's a square full of graph paper. On the grid, draw a bar chart of current against number of metal discs. Fairly straightforward, you think. You have to draw a bar chart of the current against the number of metal discs. Okay. Here's the example. So now there are 2 examples, two examples of student attempts from the exemplar document. And I've blanked out the examiner's marks and the comments. So all you've got here is the student's attempts at the question. I haven't shown you what mark the examiner gave them on their explanation of why they gave them those. We'll look at those in a moment. I've reproduced the mark scheme extract here to prevent you as needing to flip backwards and forwards to the previous slide. So I'm going to give you a moment or so. to think, what mark would you give to the attempt on the left and to the attempt on the right? So two different students here, one on the left, one on the right. You can see the mark scale at the bottom, mark scheme on the bottom for this part. So what marks are available for? What mark out of 4 would you give to the left-hand attempt and the right-hand attempt? What I'll invite you to do is think of that and then perhaps put your marks into the chat so you can compare. So exactly as Milika has done, left-hand 3. You can't give more than 4, you can't give less than 0. So no matter how brilliant or rubbish you think it is, that's the range. It can be 0 or 1 or 2 or 3 or 4 for each of the two. Excuse me. And I'll stay quiet for a moment or two while you mark and put your marks on the screen. Oh, Grace has said, I missed the first 30 minutes. Can I get a recording of this session? And yes is the answer. A link will be emailed to you after the session where you can download the slides and a recording of the session so far. So yeah. Okay, there seems to be a bit of consensus growing on the left-hand one being 3 marks. A little bit more variety on the right-hand one. We got a 1, another 1, a 2. Quite a lot saying 3 for the left-hand one, 2 for the right-hand one. Let me reveal the answers to you. I say the answers, let me reveal what the examiners said. We don't always agree with the examiners, but they are the examiners. So what we're looking at in these exemplars is how do they interpret it. And you can see that they've agreed with the consensus in the room here. The one on the left lost a mark, so got 3 of the 4 marks. So the left-hand one got 3 marks, the right-hand one 2 marks. That's what the examiner came down on. Quite a few people came out, so well done. Clap yourself on the back if that's what you got. You can see a further explanation. Student on the left gave a non-linear scale. You can see at the bottom 0, 2, 5, 6, and so lost the mark, so they couldn't get the mark for the linear scale. On the right, as several people pointed out, it's not a bar chart. Student got the scales correct, but attempted a scattergram or a line graph, whatever you're calling it, and omitted a label. So only got 2 marks. And you can see they've highlighted. The question says bar chart. Glance back at the question. Have we answered the question that was asked? The question said a bar chart, and that's clearly not a bar chart. So yes, 2 marks for that. The point of this, I mean, actually quite a lot of people here agreed exactly with the examiners, and it's a relatively straightforward, objective question. But in the more complicated questions, when you do this sort of activity, you can get quite a range of marks. Remember, the purpose of doing these activities is not to challenge the mark or the question, but rather to understand how the exemplar can help to get us as teachers to apply the mark scheme as if we were examiners. So as I said, to get inside the head of the examiners. So really good activity to do in a department meeting where if you're fortunate enough to be in a centre where there are several people teaching the same subject at the same level, if other people are teaching International GCSE Physics as well, to get a time when you get somebody photocopies the questions for the exemplars here and blocks out the marks and the commentary. Everybody has a go at marking them blind, as you just have done, and then discuss why you've given those marks, and then compare that with what the examiners have given and their commentary. Okay. Mahira, for example, you've asked why to award the 2nd mark for right diagram. I can't answer that, not because I don't have my own views on it, but because all I'm saying is what these exemplars tell us is this is the way the examiner marked it. So we might disagree with them, and I've disagreed with them myself on 1 or 2 occasions, but it's a bit like, I don't know whether you're fans yourself, but I watch quite a bit of live football, and in the UK now, in Premiership football, we have a thing called VAR, Video Assistant Ref, and they will award things like offsides and penalties and fouls, and we stand there shouting at the TV screen because we disagree often when they've given the foul against the team we support or when they haven't given a foul against the team we don't support. But the point is not what would we give in that situation, but why is the referee doing what they're doing? So it's telling us how they're interpreting the rules. We might disagree with it, but we have to accept that it's useful to know how the examiners are interpreting these marks. So as I said, we're not really, the purpose of these is not really to challenge the mark, but to understand how the markers, how the examiners are using these mark schemes. Because you'll remember, if you have had any experience of doing exam marking, not only do you mark the papers yourself, there are then moderation meetings and standardization meetings where lots of markers come together with a senior examiner and discuss why particular marks are given, and then they remark with that. So there's been quite a lot of debate and discussion on how to apply the mark scheme fairly before all the marking is done. There's always going to be scope for interpretation within there, but you have to see there's been quite a lot of effort going in with teams of examiners to ensure that everybody is marking them to the same level using the same standards. Okay. But as I say, really powerful materials, really useful materials for us to use as departments, for us to use as individuals, as teachers, but also, I would argue, to use with students. When students are getting close to the stage where they are revising for their exams, looking at lots of past paper questions, it's a really useful exercise to do with them too, because particularly for the multi-mark questions, things like the extended open response questions, where there are 4 or more marks available, it can be really useful for them to have a go at marking some questions and then see what the examiners have given, because it really embeds in students' minds what the difference is between an average answer and a really good answer. Why is this answer worth 4 marks, whereas this one, which looks okay, is only worth 2 marks? So it can be a really powerful exercise. I mentioned earlier on that when teachers mark exam papers, we tend to be a bit harsher than the examiners themselves. Students, you'll find, tend to be the hardest markers of all. When they're marking other people's attempts, they are really harsh markers. They will knock off a mark for anything they think is not exactly as they would have done it. So it's really useful exercise for students to see how are the examiners marking these questions. It'd be really good work. Okay. This slide shows the additional information that's provided by the examiner. So still on the exemplar we've just been looking at, there's quite a bit of information then in the exemplars about the question as a whole. Now, most of this is about the earlier parts of the question, so not really relevant to what we've just been looking at. But as you can see, I've produced all of it here on the screen, and you can see there's quite a lot of information about which assessment objective was tested, how many students got it right. You can see almost 25% of students could not name the independent variable in one earlier part of the question. In question 6A2, almost half of the students got it wrong, and it tells you what the most common error was. And you can see the very last sentence is the one that refers to the bit we've just been looking at. Many students made simple errors when drawing the bar chart. So there's quite, in addition to examples of real students' attempts at the questions and the marks and the commentary, you also get some analysis of how students did on this question and whether the question itself was good at differentiating between successful and less successful candidates, and what proportion of students got it right, and so on. There's really good feedback information on these. Here's an example of an extended open response question that's based on the astrophysics topic. And on the next slide, I'm going to show you the mark scheme. So you can see it's an HR diagram, a Hertzsprung-Russell diagram, which shows the relationship between absolute magnitude of stars and their colour. And you can see that's how the classification is done. The diagram shows 3 stages of evolution for stars of similar mass to the Sun: white dwarfs, main sequence stars, and red giants. Describe the evolution of stars of similar mass to the Sun. You should refer to the temperature and brightness of the stars in your answer. And as you can see, this is a 6-mark question. Here's the mark scheme. There are 10 marking points, MPs, so MP1, MP2, all marking points, 10 marking points, and any 6 of these might be included to gain full marks. So there are lots of opportunities for students to pick up 6 of the marks. And other acceptable alternative wordings as shown under notes. So for example, if they've said the brightness or temperature of a main sequence star depends on its mass, if they've said size instead of mass, that still allows that marking point 4. Worth pointing out, I did say yesterday I made a bit of a distinction between the international GCSE specifications and the UK specifications. It's particularly relevant to people who might be joining this session who are teaching in a school perhaps based in the UK, but an independent school or an international school based in the UK, which might be offering both UK and international GCSE options. This is one of the areas where there are significant differences. There's a significant difference between these mark schemes for the IGCSE and the different level-based mark schemes for similar questions in the UK GCSE. So as I say, it might be irrelevant if everyone on the call is logging in from overseas locations, but there are schools within the UK who do use the international specification. Okay, so it's worth just mentioning that distinction. They are this marking scheme is quite different from a similar UK one on that specification. And this is the feedback in the examiner's report on the question we've just looked at, the Hertzsprung-Russell diagram, and it identifies which parts were generally done well and which parts not so much. So you can see question 4 discriminated well between candidates, and this new area of the specification, astrophysics wasn't in the specification before 2018, this new area had clearly been well learned by most candidates. Most responses communicated the correct stages in the evolution of stars of similar mass to the Sun and also in the correct order. Those candidates who commented on the changes in temperature and brightness often gained marks for describing the correct changes in temperature, but gave incorrect statements about the brightness. Candidates were expected to interpret this information from the absolute magnitude scale of the Hertzsprung-Russell diagram, and many candidates incorrectly assumed that a more negative absolute magnitude corresponded to a dimmer star. So it points out some of the common errors that students make. The best candidates produced well-structured responses that presented all the evolutionary stages in the correct order, whilst commenting on the changes in the temperature and brightness between each stage. I think, as I mentioned before, the examiner's feedback is not really that helpful to the students who've just done the exam, because for most of them it's over and done with. It's extremely helpful for students who are following them the next year's cohort. So, if teachers are reading this and using this, it tells a lot of information about these are the sort of questions that are being asked. These are the common mistakes that students make, where they score well and where they score badly. Pay heed, pay attention to what works and what doesn't. So really good information for teachers and younger students about how they can improve on what their older sisters and brothers did. What if they correctly stated 3 out of 6 statements? Will they get 3 marks or 0? No, if they correctly stated 3 statements, they will get the 3 marks. Yeah, yes. So they can get up to 6 marks. What they can't do is get over 3 marks. So yes, they get, if they got 3 statements correct, they will get 3 marks. Okay, let's have a look at assessment of practical work. We mentioned teaching practical work and supporting it. Let's have a look at the assessment, how that's assessed. The core practical guide here is downloadable from the Pearson website. It's on the same page under the qualification guides. I will just put that into the chat in case you can't find it. So put it to everyone in the meeting. Oh, doesn't appear to be allowing me to copy that. Let me try that again. So it doesn't appear to be allowing me to put this in the, no, it won't allow me to put that into the, okay. So, sorry, I'll show you again later on the page, but the home page of Pearson Edexcel. On there, if you remember, there are the hyperlinks down the right-hand side. If you go into qualification guides in teaching and learning materials, you can find this booklet. Apologies, I tried to put the link in there, but it won't allow me to copy that into the chat. As mentioned earlier, all of the assessment and practical work is in the written exams, and it's about 20% of the total marks. There's no practical exam or any assessed practicals, as used to happen in this course. And this increases the need over what might have happened in some specifications before 2017. This increases the need for learning during practical lessons to be planned carefully so that students develop the skills that are necessary to tackle those exam questions. The core practical guide, you see the front cover of it on the right here, is an invaluable tool to aid this area of learning. I'm going to spend a little time just looking at what's in this core practical guide. Here's an outline of what's included in each chapter of the core practical guide. For each of the core practicals, it includes links to the relevant specification content, introducing the practical, so basic practical guidance on how to carry out the experiment and sometimes alternative ways of doing the same experiment with different equipment or different facilities, questions you could ask to enhance learning, skills that are covered in the practical, related math skills, and then examples of one or more exam questions related to the core practical, complete with mark scheme and examiner comments. So let's just look at an example of one of these core practicals and how it's presented in the core practical guide. Each core practical links to a specific point or points within the content. As I mentioned yesterday, it's advised that the core practical and other practical activities are taught when they arise within the teaching of the content, not divorced from that delivery in special practical lessons. They're effective ways of delivering the content, and both content and applications in different contexts are more likely to be learned when they're taught together. So here's the core practical based on the frequency of sound, and it's specifically linked to the 3.27p in the specification. Core practical to investigate the frequency of a sound wave using an oscilloscope. And you can see there it lists each of the 5 specification points that are linked to this core practical, that are related to it. 3.24 down to 3.29. They're all in bold, they've all got a capital letter P, so it means this is a core practical specific to students who are doing separate sciences in IGCSE Physics, not students who are doing just the physics component of the core of the combined science specification. One or more ways of carrying out the experiment are outlined. There's further information, including alternative practicals and other approaches, and they can be found by following the hyperlink, which is, the blue word here underlined down at the bottom there. So you can see, introducing the practical, the best input signals come from either skillful whistling, a signal generator connected to a loudspeaker, or more recently, a tone from an app on a suitable smartphone. The microphone should be connected to the Y input of an oscilloscope. Both time base and Y amplification can be altered for the same signal to get between 3 and 10 complete oscillations on the display. Once the time base and Y amplification, the gain, are fixed, the frequency and the amplitude of the sound source can be altered. The number of divisions for several periods can be measured and an average calculated. This average is then multiplied by the time base to give the period. The frequency is given by the reciprocal of the period, 1 over the period. The period is likely to be in milliseconds, so care must be taken to complete the conversion correctly. So quite a bit of information about how to do the practical, how to do it in practice. And there's more information, as I say, on the hyperlink at the bottom on the Practical Physics website. The questions to enhance learning are a really valuable part of the core practical guide. It's strongly advised that they're not just all set as written or homework questions, but rather used in class when setting up the practical to get students to think more deeply. In other words, to encourage some higher order questioning. Our students need to think not just what are we doing or what equipment am I using, but why this piece of apparatus? Why am I using this technique as opposed to alternative methods? Questions asked in the exam will include challenging students to apply their knowledge and understanding gained in the context of one experiment to investigate a practical situation in a different context. As I mentioned, examiners' reports tell us that students find these questions particularly challenging, and we need to be preparing them for this by promoting deeper understanding of apparatus, techniques, and analysis when they're doing the practicals. The section at the bottom here, skills that are covered in the practical, identifies the transferable skills and techniques which students may be required to apply to different contexts in an exam. So you're having technical issues, Omnia. Yes, a copy of the slides is available and you can download it. You'll be sent a link both to a recording and to be able to download copies of the examples. Are these examples of practicals conducted in a lab? Yes, is the answer. Yeah, yes. And in fact, you can now on the Pearson website download things which were produced during the pandemic when some schools were finding it difficult to do practical work, where there are examples of videos of people carrying out the core practicals are all available now online. I would strongly recommend you against simply making it easier and using them instead of the practical, but yes, I do. They are useful as a sort of checkup and also to see how it works. Useful resource for teachers as well, or when you're doing revision. Can we get the recording video of this training? Yes, there's a link available to you. It's sent within a day. There you go. Fiona said recording will be available tomorrow. So yes, you can get a recording of the training. And also within the core practical guide, there are examples in the same section of the core practical guide, so still related to this core practical 7, example of part an exam question that's linked to that core practical. Does a candidate have an option of giving a practical paper? No, there's no practical paper available. All of the questions, and it's not a separate practical paper, it's embedded within the final papers. So questions linked to the practicals are embedded within the questions, which also testing theory and content, knowledge and understanding. So unfortunately, that's not available. Okay, and the mark scheme for the example question we've just looked at is also included to show what type of answer gains marks. And it also has in the box at the foot of the screen, examiners' comments on how this question was tackled when it was set and common errors or misunderstandings. So quite a lot linked to each core practical, not just the practical itself within that core practical guide. Just want to ask you, what are the implications of the way in which practical skills are assessed for our teaching and learning? In other words, what are the implications to us when we're doing core practicals or other practicals linked to what we've just seen about the way in which they're assessed? I'll just give a moment for you to think about that, and if you like to put any comments that you might have in the chat box. Yes, I mean, just in additional answer to your question, Hassan, about a lot of students not really being keen on practicals. I mentioned yesterday, and I'll repeat it, that a common repeating song in the examiner's reports is that it's very clear from the answers they see that some students have not experienced all of the core practicals or haven't had much practical experience, and they say that sadly it shows in the quality of their answers. It's very clear when students particularly haven't had experience of things like electrical circuits and some forces setups and so on, and it does handicap them in terms of their ability to tackle the exams effectively. So they do say each year, they say they do encourage as much practical experience as it's possible to give students. Okay, I'm going to move on to make best use of our time to look at exam technique. Mentioned earlier the rubric that's at the start of the physics papers, and here's a common rubric that's at the front of our exam question papers. Just want you to consider which points you might want to draw students' attention to in preparing for the exam, and possibly to include when you're teaching the subject. The ones I would want to draw attention to, can I get arrows to appear? Yes, I can. There we go. There may be more space than you need. Oh, hang on. Yes, there may be more space than you need. The key point is, have I answered the question which was asked, rather than have I filled the space which was provided? A quick look at the exemplars in the examiner's report show that answers that achieve full marks are not always longer than those achieving lower scores. The answers are marked, not weighed, as I often say to students. So they don't have to fill the space. It's important that they fully answer the question. Showing the working in a calculation. That arrow hasn't quite lined up with that bit, has it? Showing the working in a calculation is essential. If the final answer is correct in a mathematical question, then all of the marks are gained. But if the answer is incorrect, many of the marks may still be awarded for correct steps, including for steps which are correctly carried out with wrong data from a previous step. It's what's called errors carried forward, or ECF. So really, really important for students to show all the steps in any calculations and to state the units. Really well worth, I must admit, I'm the sort of old-fashioned teacher. I won't mark students' work if they haven't shown the working for a calculation. If they just put an answer in, it doesn't get a mark. Now in the exam, that's different. The examiners are kinder than I am, and if the answer is correct, it will get full marks, even if they've shown no working. But if they've made a simple error and the answer is incorrect, they can't possibly get anything other than 0 if they haven't shown their working. So please, please, please insist on your students showing the stages of their calculation on the exam paper. Third arrow, as a very rough rule of thumb, sorry, is this always the case? So just looking at the question. Is this always the case that if the final answer is correct for a calculated question, then the student will get all the marks? Yes, it is. I mean, I don't agree with that principle, but that's the case. Yes, yes, that's true. Both in this paper and in other science papers with Pearson Edexcel, if the final answer is correct, even if they've shown no working, then the student will get all the marks that's available for that question. Do graphs need to be drawn in black ink and diagrams? No, pencil is acceptable as long as it's clear, as long as it's not a really faint pencil. If it shows on the scan, and so in other words, if it's a clear black pencil, that would work too. So they can sketch graphs and diagrams in pencil. Sorry, I was about to say with the third arrow, as a very rough rule of thumb, a minute per mark is a guide to the time to be spent on each question. And we'll mention that in exam technique later on. And also, read each question carefully. Absolutely essential. Students often lose marks by not answering the question that was asked, but writing something else about the topic raised in the question. The answer may be correct science, but if it hasn't answered the question, it won't get the marks. And it's the command word which is absolutely key to this. First part of good exam technique is preparation. Practice is important so that students know what to expect and they feel comfortable and confident when they see a paper. Not only should they practice past papers, but incorrect answers should be discussed and students should have another go so they can understand what they did wrong. This can be done as self or peer assessment using the mark schemes. We'll look at one suggested strategy on the next slide. So, effective exam techniques need to be practiced by students using past papers or part papers, perhaps homemade papers using Exam Wizard tailored to suit the exercise or focused on the particular technique being practiced. Oh, sorry. I've just seen Amara's other question. Rephrasing the question: can graphs and diagrams be drawn in black ink? Yes, they can. They can. I just find obviously it's hard to correct if you make an error on it. So I tend to do diagrams in pencil. But yes, they can draw them in black ink, and that's absolutely fine. Now, Milika said even if some steps are incorrect, um, yes, yes, if the answer at the end on the line is correct, if they've shown the steps they're working and there are mistakes within it, but they've still got the right answer at the end, they get full marks for it. Yeah. Sorry, back on the slide. Give students effective exam techniques need to be practiced by students using past papers or part papers, perhaps homemade papers using exam wizard tailored to suit the exercise or focusing on a particular technique. Give students such a paper to practice how to access it. Give students mark schemes so they can learn what's expected. Having a go-to strategy, a starting point, can build confidence and reduce the stress. It'd be hard to of what to do first. It'd be hard to overstate the stress that some students feel in the first 5 minutes of an exam. And having a sort of thing that calms them down and gets them into being able to apply what they know can be so powerful. So having a sort of starting strategy can be really useful. Here's one that I've used with students. One way to tackle a paper. Look through the whole paper first, underlining, or better still, highlighting the command words in each question, so that when you look back at the question, you remember what it is the question is asking. Decide which question to do first. Start with the questions you feel most confident with, which is not necessarily question one. There's absolutely no reason on earth why students have to do question one first and then question two, then question three. If they start with one or two questions that they're really confident with, it calms those nerves, packs some marks away into their book, as it were, but also gets students settled, and they're more likely to be in the zone when they tackle the questions that they're finding harder. Read the question carefully. Don't repeat the question stem in your answer. It doesn't lose you marks, but it just takes up space and doesn't gain you any marks either. Don't give up on a whole question if you find one section of the question difficult. Move on to the next part. And the same strategy holds for whole questions that you find difficult. Move on. Come back to missed questions and parts of questions when you've picked off all of the low-hanging fruit. Just briefly, are there any strategies that you share with your students about exam technique rather than about physics itself? Any strategies that you share with your students that you found to be effective? I'll just give a few moments for people to put suggestions into the chat box. I mentioned it a couple of times. The command words are absolutely key. So to what the question is asking, and students need to be familiar with what the command words mean. They're highlighted within the specification, but students need to know the precise meanings of these command words, such as describe, explain, calculate, justify, evaluate, uh, devise. You know what these mean. I guarantee if you ask a group of students, quite able students, what's the most important word in a question, they'll often refer to the word which relates to the topic, so radioactivity or waves or whatever it is. But no, the most important word in a question is the command word. It usually comes fairly early on in the question, and it's that which says, what are you being asked? What is this question asking you to do? I usually emphasize with underlining the command words. Absolutely, totally agree with that. It helps the students focus on those words rather than reading the whole question again and again. Yeah. I think the question the students need to focus on is not what is this question about, but what is the question asking me to do? What do I specifically need to do to answer this question? As I said, that technique of glancing back at the question when you've just answered it is a really useful thing to do. Glance back, have I answered the question that was asked? That's particularly helpful when there are little lines at the end of questions that are easy to forget. Quite often there'll be a question with quite a lot of wording asking for a calculation, and then in the last line it will say state your answer to two significant figures, and it's really easy for the student to get tied into the calculation, work their way through all the working, show all their working, write the answer down, and forget that little throwaway line at the end, and that might be worth one of the 2 marks available. If they glance back at the question, they can see, remember it asked me to state it to 2 significant figures. So that technique of glancing back at the question when you think you've finished, just to check, have I answered the question, can really save a lot of marks that the student knew, but it's easy in the stress of an exam just to forget about. The recording video of this training and are all available and will be sent to you within a day, or the link to them will be sent to you within a day. As I said yesterday, it's sent to the email address that was used to register you on this course. If you registered yourself, no problem. If someone else, like an inset coordinator or an exams officer, registered you, that's the email it will be sent to. So worth checking with them. Okay, let's press on. Almost towards the end now. Just to mention, walking, talking mocks. You might have heard of these, you might have tried them. There are Pearson videos available online. They're on YouTube, but they can also be found via the Pearson website too. Videos of science examiners and trainers delivering roughly 10-minute walking, talking mocks. They can be used directly with students, but they're also good examples to model how teachers might run walking, talking mocks themselves. This is the basics of how it works. Students sit in the same exam room where they will do their final exam, preferably in the same seats. It can be done in the classroom, but it's not always as effective in building confidence in exam conditions. Students are given an exam paper which is as close to being like the real thing as possible. And then students are literally walked through every question on the paper. If you as a physics teacher are doing it, you would literally talk students through, this is the question I'm going to tackle, this is how I'm going to start, what's the question asking, underline the command word, think this is the question, what's the first thing I'm going to do, might draw myself a diagram, might write down that. So you literally do everything you do and commentate yourself as you're doing it. So you talk students through the smallest steps, how to plan, things to remember, and so on. You might focus on a particular area, such as mathematical questions or questions based on a practical investigation. And then when you've walked through the paper and done it yourself, immediately afterwards, students then tackle the paper themselves. They've just seen you do it, so it seems like they're repeating themselves, but no, it really gets them into thinking, this is the way to tackle a paper. So they then write their responses in timed conditions. Hopefully they'll do very well at it because you've just shown them how to answer all the questions. But it's people have found it a really effective learning technique and a really good way of giving students a strategy and calming those nerves in an exam. As I mentioned yesterday, strongly recommended contact with the dedicated subject advisor, Irene. She's the dedicated subject advisor. She's always happy to answer questions or queries. It's easy to contact her. As I say, I think her name is spelled incorrectly on this slide. It's Irine. And if she can't get back to you immediately, she'll respond as soon as she can. So you can contact her either on the online form at qualifications.pearson.com, contact us, or by emailing her directly. And you can also sign up, as I mentioned yesterday, to the regular email catch-up or update link. So if there are any changes or different information available, she'll send you an update on those. So as I said at the end, we come to the end of the content for today's session. I'd invite you, if you want to share in the chat box one thing you'd like to do as soon as you return to your classroom or department. We've now come to the formal end of the content of this presentation. Thank you so much for being involved. If you have no further questions, you're welcome to leave the session. As I said, within the next hour or day, depending on how quickly it happens, you'll be sent a link to be able to download the slides if you want them, to access a recording of the session if you want to. You should also be sent a certificate of attendance and a link to complete an evaluation, which I'd encourage you to complete if you can. But if you have any questions, we've still got some minutes left of our time, so I will stay online for a little while to take up any questions that I'm able to. Thank you very much for getting involved, and good luck with your students.